In this chapter, we're going to study the process of creating concurrent or multi-threaded programs in Java. Concurrency is a very complex topic, and we're only going to be able to lightly touch on how to do multi-threaded programming in Java. But we are going to at least give you the opportunity to see some examples of creating programs with multiple threads. For those of you who aren't familiar with the concept of multiple threading, I have provided a diagram from the wiki page for thread. And the way a thread works is, first of all, you can think of the programs you've written in Java so far as all have been computed in the main thread. So whether you knew it or not, your programs have been running in a thread. It is possible to create a program with multiple threads. And so what happens is, when you create multiple threads, you can have one computation occurring in one thread, while a separate computation is occurring in a separate thread. There are lots of examples of programs that would benefit from this, such as chat programs where the chat server establishes communication with a chat client in its own thread, or a graphical user interface program that captures user input into the GUI in one thread and does some sort of numeric or computational process in another thread. And there's many, many more examples. In simulation, for example, you might have each object that's part of the simulation doing its processing in its own thread. At any rate, in this lesson, we're going to look at just a simple example of how to create a program with multiple threads. So let's go ahead and look at that program now. We're going to just look at a program already written and then run it rather than enter it from scratch. It's a little complex for that. And I should mention that some of the example for this program comes from one of the books I've learned Java programming from. It's titled Java Programming Advanced Topics, written by Wigglesworth and Macmillan. That Macmillan is no relation to me, by the way. So this program is a program called TwoThreads. Notice we've imported java.io.star. And what we do is, in the main part of the program, we create a thread. So we have a data type called thread, and that thread is assigned the result of calling the constructor for a class we call user interaction, and you'll see it down below. Then once we've set up the thread, then we call the start method to start the thread. Then we create a second thread called second thread, and we assign it the constructor of another class called compute log. So then we start that thread. After we've started that thread, then we call the join method of the first thread. The join method waits for the thread process to terminate. And then once that thread process is terminated, then we'll go to the second thread, and then we call end to it. And we actually have to cast our thread back to compute log because the end method is part of the compute log class, not part of the thread class. So now let's take a look at our two classes. They're fairly simple to understand. User interaction simply prompts the user to answer a couple of questions. Hello, how are you? What are you doing today? The other class, compute log, simply continually computes the logarithm of the value of I, the current value of I, starting at 1. And we did that because that's a fairly processor-heavy task, and it would lend itself to be operating in another thread. And then this loop runs while a variable stop is false, and so the end method of the compute log class simply assigns true to stop the thread and in essence stop the program. So let's run it. Go back to our command prompt. I've already compiled it, but I'll compile it again. So understand that the second process, compute log, is running in the background, and we computed up to 11,880. So at the point where I entered the second prompt, the first thread was joined, and then the second thread was ended, and that's when it stopped. So that's how you create multiple threads. It's very simple to start them. But like I said before, actual concurrent programming is quite complex. One problem we have is that if we're creating object-oriented programs where we use inheritance of any type, we have a problem just using the thread class as a superclass. Notice that user interaction and compute log both extend the thread class. The problem is if I have, for example, a vehicle class that then in turn derives another class from that called car, I can't also extend that class to include thread. So what we have to do instead is we have to write our classes as implementations of an interface called runnable. The runnable interface allows us to create a derived class that's derived from a base or superclass that also can be written in its own thread or written as a multi-threaded program. So in the next lesson, we're going to take the two threads example and see how to implement runnable in order to write it as a multi-threaded program.